Okay guys, today I want to talk to you about finding an error for an alternating series. So it's something I talked a little bit about in the last video, that if you're following along with a series and you know that you're stepping forward and then you're stepping back and then you're stepping forward and stepping back, and each step is less and less and less and less, one you know you're going to converge. That is the alternating series test. This series that we're given here, yeah, it fits that alternating series test because it's alternating. You have the negative 1 to the nth power, so one term's positive, then negative, positive, negative, and so on. It's also got its terms decreasing. If you absolute value this, its terms are going down, okay? So now, we know with this alternating series that when you take a step over, whether you're going to the right or left, you're taking a step over where it converges. And then the next step is going to go back over, right? You're going to go over where it converges, and then but each step is smaller. So we say that at the very most, if this series has a value of s, that the nth partial sum and the series s is going to have a difference. That is, they are going to differ by less than the next term, not the nth term, but the n plus 1 term. Okay? I may have written that wrong in the last video, but it is going to be the next term. Well, this is the nth partial sum. This is the next term. Well, we want the partial sum to have a error of less than 0.01. Then we're going to create this term. This term is going to be 2 times negative 1 to the n plus 1 all over n plus 1. And we want to solve and know how many terms it is so that this value is less than or equal to 0.01. All right? And so that's not too hard to do, right? The absolute value is going to get rid of this negative right here. We're going to end up with 2 over n plus 1 has to be less than or equal to 0.01. If I take the reciprocal of this, I get n plus 1 over 2 is less than or equal to... Nope, I'm sorry. When you take the reciprocal, you've got to flip your signs, because the smaller side when you take the reciprocal is going to be bigger, and the bigger side when you flip it's going to become smaller. So this is going to be, has to be greater than or equal to 100, because that's 100th. Multiply by 2, we get n plus 1 greater than or equal to 200. So n has to be, this is going to be greater than, not equal to. It's going to have to be greater than 199. So as long as n is greater than or equal to 200, we're going to be within 100ths of the actual value of the sum. All right? But unfortunately, that's a lot of terms. You got to go out 200 terms to have that, to have an error of less than 0.01. All right? It would be equal to 0.01 at 199. It's going to be less than if we go out any more terms than that. And so that's how essentially you can find the error bound on an alternating series. Just make sure that you look for the n plus first term such that it's going to be less than that error. Set it up, solve it, and you'll be all good to go. All right? Have a good one.